How do you determine when a nuclear fuel rod is no longer usable? That's a really great question. And it's a combination of things. Part of it is just modeling and simulation, but a larger part of it is just measurement. We look at how far a poison rod has to go down into a nuclear reactor while the fission process is taking place. And as that poison rod has to be removed, that's supplementing the fact that the fuel is being burned up and is creating poisons. Basically, the fission products themselves are largely a neutron poison. And so by coupling those two together, we can figure out how much reactivity worth each rod has. And when we know how much reactivity worth each rod has, we figure out which ones are spent and which ones aren't, which ones can continue to maintain the criticality scenario and which ones can't. And that's how we figure out when they need to be replaced. So typically a core on average, depending on how you fold in the ones that are being reused as they move around the core, it's around 2 or 3 years per core. And why that's really substantial is because a core might be, say, 10 meters on an edge or something like that if it was a cube. And that lasting 2 or 3 years gives you, for a gigawatt plant, a nice relative perspective for something like coal, which requires around 100 rail cars of coal per day. And so a little bit of a rabbit's trail there, but thanks for the question. Have a good day. Bye.